Bharti. We are talking about fluid statistics. There in the last video we have ended in a point where we are discussing that the fluid, if it is in equilibrium or in a static condition, the pressure will varies when it will moving down into the depth from the surface of the fluid, and in the same way, if I consider the horizontal line on a fluid which is parallel to the surface or surface itself, there is no difference in pressure can be noticed if it is in equilibrium or static condition. That means my point of saying is that, let's say this is a container. So if I want to represent both together, there is a liquid here. Okay, so while I am going down into the liquid, pressure increases, or you can say increases with depth. Okay, and second, at any horizontal line, pressure is equal in the fluid. Okay, so these are the two conditions, and to fulfill this condition, and third condition is that the net force along the horizontal direction is equal to 0, and in vertical direction only atmospheric pressure exerting. Okay, so the condition will be said to be in equilibrium or static. So that means if a fluid is in a static or equilibrium, we can say there is no extra force is exerted on the fluid apart from the atmospheric pressure, which is universally accepted or present. In this condition, there will not be any pressure difference along any horizontal line. If I take anywhere in the fluid, okay, and the pressure will increase if I go down into the depth. So this is the condition where liquid in equilibrium condition. So up to that we have understood. So there is no net force acting on that. So in contrary, there could be one thing automatically will come in mind. If in case we put force, additional force, that means F net is not equal to 0, that means greater than 0, it cannot be negative, so it has to be more than. If it is more than 0, then what are the effect coming on the pressure with the same liquid in the same container? Okay, if I consider the same liquid, same fluid in the same container, what would be the effect? So effect may come vertically, okay, vertically or horizontally. So these are the two things may come if I disturb the equilibrium, that means I am putting any extra force. So let me understand first what are the disturbance and how it is affecting, then after we will go to that. So F net, you may have experience, let's say we have a bucket of liquid wherever in a household we are keeping a bucket of water, say, and if you suddenly want give a what you can say punch on the water column here, if you put a punch, if you keep a punch, you see the water column starting from there will starting waving. Okay, it is start a wave and it is going towards the end. Now why this thing phenomenon is happening? You are punching here and suddenly the water starting waving and it is moving towards the boundary of the bucket. So why? Because what have we learned, whatever force in turn it is pressure, if it is given on the fluid surface, it is increasing the pressure. So the force exerted, extra force exerted apart from the atmospheric pressure, it is increasing the pressure. So in this part, if I say it is a column where this force is affecting, so this will increase the pressure from atmospheric to additional pressure. This pressure will transmitted into this liquid in all direction. So when it is coming to the surface of the liquid, it will try to move this liquid up due to this extra force, and it will start jumping somewhat, but due to the weight of that water, it will try to come down. So when it is coming down, it is again exerting a force and it will turn the next part of the liquid to move up, and slowly it is going towards the end, and that is happening on the both sides due to the disturbance caused due to the force in this area. Okay, this is the experience or the experiment you can able to do at your own arrangement at home. Okay, so this is the case. So this can be understood better if I have this kind of container. If I manage to have this kind of container and put, let's say, water inside it with the up to some height, so unless and until we put any force, it will be there in the same height on the both arms automatically. That practically you can see it. If we pour water, it will be there in the same height. Now if we are putting a piston there and putting an additional force here, you can see the water column will come down here and it will move somewhat up. Okay, so this is the case you can experience, you can see. So when that extra force is given, that is turning into a extra pressure on the water column, it started moving on the area where it is possible, and it will move at the free area where there is no resistance of the resistance of the flow. So that means two criteria you can understand. There is a extra force, that net force, if it is more than 0, will cause fluid to flow. So that means one of the criteria for flow of fluid, there is a difference of pressure. So fluid flows, we can conclude in other way that fluid flows due to difference of pressure. This is the one thing. Another thing we can conclude that what we can see, the fluid will flow from this side to that side. That means fluid is flowing from higher pressure. This is the high pressure zone, this is the lower pressure, this is only atmospheric is acting, there is atmospheric plus the additional force we have created. So fluid is flowing from higher pressure to lower pressure. So the second conclusion is that fluid flows from higher pressure to lower pressure. So these two things we can conclude regarding the fluid. Fluid will flow from higher pressure to lower pressure, and what fluid will whatever fluid is in flow, that there is a imbalance in force. So imbalance force in the fluid will cause fluid to flow. So that means we can say the state of static of a fluid will change into the flow when there is a imbalance of force or there is a disturbance in the equilibrium. Okay. Now the topic we'll bring is what is the effect of force on the system, or is the effect of force on the system containing fluid. So the effect here that we will talk about the effect in terms of pressure energy. So the effect what we will learn here, it is only the effect on pressure. So what is the effect on pressure due to force on the system containing the fluid? That means if a container is containing a fluid, as we have learned earlier also, in the same case, in the same way, where we are describing a container containing the fluid, you can assume the same fluid. It will be easier to understand what is the effect on pressure if I give a motion in terms of acceleration. So the first thing, effect vertically effect vertically you can say. So we are talking about the effect on pressure vertically. So how we are moving? We are moving with an acceleration A. That means the total system that I am giving a acceleration to this container. Okay. So when I am moving the container with the acceleration A, what do you think the effect the liquid will experience? Because liquid is considered as the ideal. That means it is incompressible, at the same time non-viscous. So if it is non-viscous, so that means it is a separate body with a container. There is no friction which is causing in between the liquid and the container. So that means when it is a free body, when the container is given acceleration upward, this is trying to be in its own inertia, trying to be in same place, so you will experience a acceleration on the opposite direction. Okay. It will experience opposite direction. At the same time, it has its own natural acceleration, that is g, that is there in the same direction. So that means g is acting in this direction, and the acceleration caused due to the acceleration given on the container on the opposite direction will be added to the acceleration, or it is naturally there. So my pressure experience, the change in pressure, the ultimate pressure, this is the effective pressure, you can say. Effective pressure will be the pressure atmosphere that is always there on the surface. It will act downward, plus the effect due to the high column of the liquid. Now this is incompressible, that means there is no change in the height. Okay, due to this extra force causing due to the acceleration, it will not compress, so a height will be there. Then due to that, density will not change. What is effective acceleration? This is effective acceleration will be the g plus a, this moving down. So this will affect the complete pressure due to the same height of the liquid column. It will exert on the container surface inside this surface. That liquid column will exert on the container surface due to the additional effect of the acceleration. Okay. Now if I assume that acceleration is downward, then definitely this A will be on the upward against the G. So our effective acceleration will be G minus A. Why? You can say why A can never be greater than G, that is not able to create. If it is, in case hypothetically if we assume, then there is no water will exist in this container that will flow up, because if A is more, G will not able to keep it in the container, it will move out of the container. So this situation will not happen. So in this case, when it is moving up with A, and P effective when it is moving down, that means A means I am talking about the container. So the effect on the liquid column will be H rho, and effective acceleration will be G minus A. This will be the case vertically. Understood? A will the acceleration given downward on the container, and due to that liquid column will experience a opposite acceleration, and the effective acceleration will be G downward dollars to G minus A. Okay, so this will be the case. Now this is I am talking about vertically. Now if it is horizontally, what would be the case? Now the same thing, if I discuss about the effect on the horizontally. Now second is horizontally. What would be the effect? Now here I am giving acceleration this side. This is your fluid column. Okay. Now definitely, if container is moving this way, that liquid will get an acceleration this way. Okay. So if it is moving with the acceleration this way, now can you, if I assume a cylinder here, just for understanding I am assuming a cylinder which is from boundary to boundary. So there will be a pressure something here P1 say, this is P2 say. So can you make a understanding that what would be the pressure P1 and P2? One assumption that automatically should come, what is the value of P1 with respect to P2, whether P1 will be more or P2 will be more, because this is just similar the case if I turned it 90 degree, if I put it in the 90 degree, just follow my description or analysis. If I just for a while, if I say this is turned 90 degree, this is similar to the acceleration, because acceleration is downward in a container when liquid is there in static state, where the acceleration is acting due to this gravity downward G. Now if it is a water column, pressure here is P1 and there is P2. So we can assume that pressure the top of the is less than P2. The similar, this actually is nothing but the force is acting in which direction? On the liquid column. Due to this acceleration, the force is acting this direction, and if force is acting in this direction, there is no atmospheric pressure due to the boundary of that. Only the pressure which is being developed due to the force, due to the acceleration on the liquid column. Then the liquid column is accelerated from this to this direction. So that means force is coming this direction, and if it is force is coming this direction, more you go down this side, there is mass will increase up to this, there will be less mass, there additional mass will come, and if you go that, there is the highest that liquid column, that the mass will be calculated, and the force is nothing but mass into the acceleration. More you go this side from right to left, you will add up more mass. So that means whatever force is acting here due to this water column will be highest. So that means P2 will be more than P1 always. Understand? And there is no imbalance force other than this force due to the acceleration, because atmospheric pressure is acting this way. This is totally 90 degree to this force, so this will be nullified. That effect will not come in this horizontal direction. Only the force will act due to this water column, due to this acceleration. So this is the mass into force. That is the only case it will affect. So what will be the pressure? Now if I consider P2 is nothing but P2 minus P1. Rather I can take P2, or I can say that P2 here is equal to whatever P1 here it is experienced just at the boundary. Let's say it is P1, some pressure is there due to the acceleration, some mass is there, will be plus by the column of the water. This is column. Now let's say this is L, length of the column. That means I am talking about if it is a circular container, I am talking about the diameter. If it is any other shape, this is the length. So right now I am taking as a length, as a general representation, length of this water column into the rho, the density of the fluid. Not water, it is fluid. The length of the fluid column into the density of the fluid into what? Acceleration. Instead of g, it will be acceleration, because this direction there is no g, only the acceleration acting. So this is the equation I can establish due to this force. Understood? The similar way that when I talking about the gravitational force and we are talking about the vertical pressure difference, this is just due to the acceleration created and the pressure created here. Okay, fine. Just now remember, this will be the pressure difference, which will be pressure at the end of the this boundary with respect to this boundary. Okay, understood? Now this will be helpful in my next discussion, where this is a practical experience. If you move some liquid and try to move this with some motion, if you give some motion to this, as because this is liquid column and non-viscous, it will not be in the same condition. It will try to move something like that. Okay, and if the motion is constant, it will be remain in this condition, isn't it? When you try to move some liquid filled container, the liquid column will not be in horizontal, it will move something up towards the motion, means up, the liquid will move towards up and the opposite to the direction of motion. I am saying, if it is the directional motion, the liquid column will move in the opposite direction. This is a practical experience. Why it is happening? Because when I am moving with this, there is a force imbalance is there, isn't it? There is a force here, this is a force here. Okay, now as because we are moving, that this is atmospheric pressure always, this atmosphere is always there. Now if I moving, you can see there is a pressure difference here, because if we move, there is a force is acting in the highest, force acting is less. So that means there the whatever water, it will try to move up, because this is not equally, because if it is in equilibrium condition, the pressure here from the downward and the upward will be same. Now due to this motion, the pressure which is force is created, that liquid will exert in all direction. So now pressure energy here it is increasing, here it is less. Due to this pressure energy less, this column will try to move, and same thing will happen in all directions. Now as because that force here with respect to this it is less, here it is maximum force, so it will move maximum water column. Here it is further less, it will move less, and here it is just minimum. So there has happened that pressure energy to the atmosphere is trying to move down. That means pressure due to that motion here it is further reducing than the atmospheric pressure. So it is trying, and at the same time when the liquid column will move, certainly that liquid due to this gravity will try to come down. Although it is a pressure is there, but what is the weight of this? The weight of this, it will, as because it is moving down, that motion of the water, it will come down there due to the gravity, because these are perpendicular force. This will not affect this, but due to the gravity force and the pressure energy, it will come down. So it will try to fill. The liquid has also a tendency, wherever there is a vacant, it will automatically fill due to this weight of the air. So when the liquid is moving there is a vacant space happening, and the liquid column due to this weight will come down, and it will be a complete single figure, it will move. So this is the dynamics of this motion when it is being created a acceleration there. Now if it is so, this will be the case when it is moving, and I can assume this is moving with the same motion, same acceleration and all that. So there will be a steady state condition in this condition. Okay. Now if it is so, what would be the pressure here in the same line? If I consider, this is P1 already I consider when it is here due to the pressure force. This is will be the P2. Now in other way, if I consider with respect to the height, what would be P2 here? P2 here is will be the atmospheric pressure here. That means P0 plus the pressure due to the height of the column. I am just talking about this part, this single line. If the water column is your, let's say I am talking, this is H. So this is H, rho and G. And what is the pressure here? P1 is just when it is in equilibrium in this condition, then pressure here it will be the equal to the P0. So P1 is equal to P0. P1 and P0 will be same. Then only the liquid column will be in the same condition, will remain as it is. So from this two, what is that? P2 minus P1 is equal to H rho G. From this perspective, or when we are comparing the vertical pressure. So now earlier we got P2 is minus P1 is equal to L rho G. Okay, L rho, sorry, A. And now I am getting P2 minus P1 is equal to H rho G. Now these values are same in the same condition. When there is acceleration, this case also acceleration, the same container, same liquid. So I can equalize this. So if I equalize this, what I will get? L rho A is equal to H rho G. This rho will be cancelled out. Then L by H is equal to A by G by A, or the reverse, because that will be useful. A by G is equal to H by L. Why I am taking? I will tell. Now let's say it is creating a angle theta. So now if I can calculate tan theta is equal to what? This is height upon base. That means H upon L. Now what is H upon L? I am getting A by G. A by G. So if I want to calculate the theta, that means the angle created due to this acceleration, it will depend on tan inverse A by G. If I know the acceleration on the container is A and G is known, then I can calculate with this acceleration how much angle it will form. So from there I can get H with the dimension is automatically maybe there, the container, the fixed container, then H, how much height it will rise on the other end, that I can get. Okay, so I will end up here. In the next video I will move on to the other subject related to this. Okay, so thank you for now. Good night.